Good day, learners. Today we are going to study about the highest common factor, HCF, or it is called also greatest common factor, or GCF. So they are the same. Now, in factoring, we have the opposite of that, which is the distributive property of multiplication. This one is already factored. And this one outside this bracket here is what we call the HCF or the GCF. Okay, let's do the distributive property of multiplication here. So we have 3 times 2, we have 6, and then x. We have 1 plus 2, we add exponent because we are multiplying it. So we have x cubed and copy the y squared. And then we have minus. So we have minus here. 3 times 4 is 12 here. X times x, add exponent 1 plus 1 is 2 here. Y squared, and 1 is y cubed. So y cubed. And finally we have the y here, positive. And then 3 times 1 there is 3, and then x, and then y squared times y squared is y to the 4th. So this is the product of monomial and a polynomial, and we have applied the distributive property of multiplication. In factoring class, this is the given, and we are going to do the opposite. Instead of adding the exponent, we subtract the exponent because we are going to divide each of this by the highest common factor. So here class, we divide this by 3xy squared, we divide this also by 3xy squared, and the last one by 3xy squared. Now, the problem is, how do we find the HCF? The one that we are going to use as divisor of these polynomials. So this is our topic for that. So here we have 1 to 8, and I'm going to show you how to get that HCF, that term that we are going to extract from these terms. We are going to extract it and then divide every term by the HCF to get this answer. Okay, let's have 12 and 30. Now we have two methods. We have the prime factored form method, and the other one is by factors only. So it's easy to have factors only. We do this one only if we have numbers that are big. But if we have small numbers, we can easily identify the HCF mentally. So we have 12 and 30. If we have 2 or more numbers, we start the list or the smallest number. So which is smaller here, the 12 or the 30? So 12 is smaller than 30. We start here and we factor only the 12, not the 30. So let us factor. Let's start with 1. We list all or the complete factors of 12. So we have 1 times 12. So 1 times 12 is 12. Next is 2. 2 times 6. 2 times 6 is 12. Okay. Next is 3. 3 times what number to get 12? Times 4. 4, no need because we have already the 4 here. 5, no, can't be. 6, we have already 6 times 2 here. Don't put 6 times 2 there. 7, no. 8, 9, 10. So 1, 12, 2, 6, 3, 4 are the complete factors of 12. Now, in our complete factors of 12, you may just don't put any more the 1 because it's just remove the 1. Okay. So here we start from the biggest. the largest number, not on the 2, not on the 3, but on the largest factor, which is 12. So let's start with the 12. When we choose the 12, we divide all the numbers here by 12. And if we can divide it by 12, then 12 is our factor, or the highest common factor. So let's start. 30 divided by 12. Can we divide 30 by 12? That will give us an exact number or an integer. No. So 12 can't be our HCF. Cancel it. Next is to use the second to the largest number. And here that is 6. Okay. So 30 divided by 6 is 5. Therefore, we can divide 30 by 6. Therefore, 6 is our HCF. That's 1. No need to try and test 3, 4, 2 because this one is the highest of 3 and 4 and 2. Number 2, 24 and 56. Again, we choose the smaller number, which is 24. Okay. So let us start and factor and give all the complete factors of 24. So I'm going to use 24, 1 times 24. But in the IGCSE, if you are asked to give the complete factors of 24, you put 1 times. Okay, don't forget the 1, it is included there. But here we don't need the 1. So we have 24, it is actually 1 times 24. Then 2, do you have 2 there? Yes. 2 times 12 is 24. Can you use 3? Yes. 3 times 8 is 24. Can you use 4? Yes. 4 times 6 is 24. Can you use 5? No. 6 is there already. We have the 6. 7, 8. We have already the 8 here. 9, 10, 11. We have the 12 here already. So these numbers are the complete factors of 24. Okay. Where do we start and divide that one? By the highest or by the largest number here among the factors. So we have 24 is the largest. So we start with 24 here. Divide 56 by 24. If that is exact, then the 24 is our HCF. But 56 divided by 24 is not exact. So we cancel this one. This is not the HCF. So the second to the highest of the 24 is 12 here. Okay, divide 56 by 12. Can we divide 56 by 12 and give us an exact answer? So 5, no. So 12 can't be our HCF, cancel it. Next, 8. So we try 8. Now, 56 divided by 8 is exactly 7. So we can divide 56 by 8. Therefore, our HCF is 8. Don't test any of the 4, 6, and the 3 out of the 2. Okay, we have 3 here. We have 3, 12, and 21. Let's have the smallest number is 3. Okay. So 1 times 3. So we have only 3. So we need to test the 3. Okay. Let us divide the 12 and 21 by 3. If we cannot divide the 12 and 21 by 3, the factor is 1. The highest common factor is 1. So 12 over 3, yes, it's 4. Okay. 21 divided by 3, 7. Yes. Okay. Therefore, our HCF is 3. 2, 5, 11. We start from 2. So, for 2, it's only 2. 1 times 2. Okay. 5 divided by 2, no. If that is no, don't test any more the rest. Because we can't have a highest common factor here. And our answer is just like 1. Number 5. Let's have letters or variables. So we have x, y squared, and x squared, y to the 4th. When we have letters, Make sure that you have letter here. For example, you have an x here, you have an x on the second term and x on the third term. If we have only x here, but we don't have x here, x is not the highest common factor. So we have an x here and we have an x here. This one is x to the first, this one is x squared. Now x is our HCF, but what is the exponent? We choose the lower. When we have same letters here, we choose the exponent which is lesser, okay, the least. So we have x to the first here, that is 1 here, and we have x squared. We choose the exponent which is lesser or the least, so we choose to the first. Y, we have y here and we have y here, but this one is 2 and this one is 4. This one is higher, this one is lower. We choose the lower one, which is y squared, then y squared. Choose the lower exponent. Here, a, therefore we have an HCF of a. What is the exponent? Let us see the exponent. This one is 3, this one is 5. We choose the smaller one, which is cubed. So we have cubed here. Okay, let's have b. We have a b here and a b here. So we have a b here. This one is 2. This one is 4. We choose the 2 because this one is smaller than 4. So we have b squared here. We have the c. We have the c. Therefore, we have the c here. Now, this one is c to the first. There. And we have c squared. So we choose the smaller exponent, which is c. Or c to the first. Okay, we have number here 8, a to the fifth b, and 24, a cubed b squared c. Let's have the numbers first, the 8 and the 24. So for the 8 and 24, we know it's 8. 1 times 8 and 24 divided by 8 is 8, because we can divide 24 by 8. So 8 is the common factor of 8 and 24. Okay, a. We have an a here, so we have an a here. This one is 5, this one is 3. We choose the smaller exponent, lesser exponent, which is 3. We have a b here, we have a b here also. This one is 2, this one is 1, therefore that is 1. Now we have a c here, but we don't have a c here. Do we include the c? No. So this one is only our HCF. No c. Here, 2/3 x squared by the 4 and 2/3 x to the 6 y squared c squared. Here, class, we have the numbers 2/3 and 2/3. Of course, they are the same, so we can extract it to have 2/3 because they are the same. So x, we have an x. This one is to the second, this one is to the sixth, so we choose this one, x squared. We have a y here, we have a y here, then we choose the y. This one is y to the fourth, this one is y squared, so we choose the lesser exponent, which is 2. We have a z squared here, but we don't have the z squared here. Therefore, the z squared is not included in our HCF. And that is how to determine the highest common factor, HCF, or the greatest common factor, GCF.